got problem number 22, an even numbered problem from the book, up here on the board. Wanted to just take a look at this. You'll notice that both equations involve the same three types of terms. We've got some x squareds, that's a 9x squared there. We've got some numbers, and we've got some y squareds. But they're not in the same form, so I'm going to just rearrange the two equations. I think what I'm going to do is get all the variables on the left, numbers on the right. So for this first equation, I would add over the y squared. So that's going to become 4x squared plus y squared equals 4. For this second equation, it looks like I want to subtract over those x squareds. So that will become negative 9x squared plus 16y squared equals 144. Okay. So now I want to get the opposite number of x squareds or the opposite number of y squareds. I'm going to go for that because I can get that by just changing that first equation. Now to do that, I'm going to multiply through by a negative 16. It's kind of a big number. If I preferred to get the opposite number of x squareds, I could, but if I didn't want to introduce fractions, I'd need to change both equations. Multiply the first one by 9 and the second by 4. Perfectly viable option, either way should work. If I multiply this first one by negative 16, I'm going to get negative 64x squared minus 16y squared equals negative 64. I'm going to keep this one the same, so negative 9x squared plus 16y squared equals 144. And now that I have the opposite number of y squareds, if I add, the y squareds will drop out. So I'm going to have negative 73x squared is equal to, let's see, the positive number here is bigger. That's going to equal 80. Okay. Well, if I solve for x squared, I would divide through by negative 73. X squared would equal negative 80 over 73. That's not going to work. Okay. X squared can never ever be negative. So this has no solution. And that's my answer. There is no solution. If you get something like this that's not possible working in the real numbers, then there's no solution. Don't forget to actually write that. If you get to this point and stop, you haven't told me that there's no solution. Okay. Wanted to go through this example just to remind you that that can happen. Sometimes when we get to a point like this, we say, oh, did I do something wrong? You didn't necessarily do anything wrong. Graphs are not guaranteed to intersect. And here, these two equations describe graphs that happen to not intersect. Okay. So that can certainly happen, and just wanted to make sure that we had done an example of that together.